In this video you'll learn how to build a self-destructing stone bridge, just like this one. It's very simple to set up. First, we start with a cube, then we fracture that cube into pieces using the self-fracture add-on, and after that we build a geometry nodes group to make the pieces magically separate and come back together again, all controlled by a single empty. Okay, here I am in a blank Blender 3.4 file. Nothing changed at all. First we need to set up the stone that we're going to fracture. So it doesn't have to be stone, it can be wood or whatever. Just tab into edit mode on the default cube and scale it out on the Y to make it long. Scale it on the X to make it wider. And I think I'll flatten mine a little bit. Now we need to separate it, fracture it into a bunch of little bits and pieces. And to do that, use the self-fracture add-on. So make sure you have that turned on in your add-ons. Just search for self-fracture and make sure that is enabled. Using self-fracture is extremely easy. Just go up here to Object, Quick Effects, and pick self-fracture. I've actually set up a keyboard shortcut for mine, Shift Option F. You can do that by just right-clicking on it and picking Add Shortcut. So I can just do Shift Option F, and I'll get the self-fracture settings. You can't see my keyboard. Let me turn on my screencast keys. There we go. Okay, Shift Option F for me. You can set that up if you want. Okay, and we don't need to change many of these settings. Let's just change this source limit to 200. I actually don't know what a lot of these settings do. Recursion will break up pieces a second time into smaller pieces, so I have to turn that up. You have randomness, something sizes. Really don't know what most of these do, but you don't need to know a ton to get it to work. Let's see what that does. Okay, it looks horrible. I'm going to press flower Z and undo that. To make the fracturing work, we're going to have to cut some edge loops on our geometry. So in edit mode, just press Ctrl R, and you'll see a loop show up ready to be cut, and just scroll to adjust the number of loops. That looks great. And right click to leave them centered, and Ctrl R this way as well. Perfect. Let's see if the self-fracture treats it any better now. Shift Option F. And instead of particles, I'm going to select Own Verts so that it works based on its own vertices. Maybe that'll do a better job of things. And 200, 1 recursion, maybe some noise. Okay. This step, what it's doing right now is the recursion. It goes back and refractures some of the pieces into even smaller pieces. And it seems to have done a good job. So now that you have the pieces, don't unselect them. Just press M, press New Collection, and just name that Pieces. Now all the pieces are in a collection. You can easily hide or unhide the pieces. Okay, so now you can just hide your original cube and select your pieces collection, right click, and do Select Objects. All the pieces are selected now. And you can press Tab or hold down Shift and then select one of the pieces so it's in focus. You can tell because it's a lighter orange. Then just press Tab to go into edit mode on all of the pieces at once. And it always slows down a bit for me because there's a lot of geometry here. Just press A, make sure every vertex is selected. And then press M to merge. And then pick by distance. And the merge by distance cleans up a lot of double vertices. By default, the self-fracture pieces always have a ton of doubles, and that cleans them up quite a bit. You can see mine removed 2,987 down here, and that's pretty significant. So now that that's done, press Tab, go back to Object mode. Next, we're going to make the geometry nodes, now that we have our neatly fractured cube. So press Shift A, New Cube, put that in, make sure that is not in your pieces collection, make sure it's in the main collection. And I'll just name this Nodes. It does not matter what you call it, but call it something. And I'll rename this to Original Bridge. Okay, now select your node cube and go to the Geometry Nodes tab. Alright, and this node group is going to be pretty simple. It will add in a lot of noise, so it'll end up looking a little bit more complex, but for this tutorial I'm just going to hide the spreadsheet because we won't be using it for anything. Press T to get rid of the toolbar, Great, we got this nice clean setup. We're ready to go. Looks like I'm missing a piece right here, but no idea why, and I'm just not going to worry about that. Alright, press new. You have a new, and I'm going to name this bridge. Alright, and the first thing we need to do is delete the input. We do not want that. Our input geometry is going to be these pieces. Just click and drag the collection like that, and it will just turn into a collection info node. The way this will work is we're going to have all these pieces, and we're going to move every piece randomly. So all the pieces will be moved out some random amount, all of them. And then we'll add an empty object, and depending on how close that empty object is to a piece, that piece will have either more or less random movement. So if this piece is really close to our control empty, or if the control empty is really close to it, then it won't move very much. But as the control empty grows further away from it, it will move out into space to its random position. So the first step is to give them all random positions, and that is not too hard. In your collection info node, hit separate children. So the geometry coming out of the collection info node is instanced geometry, which means we can use a translate instances node to move it around. So just plop that node right in there, and now you see we can adjust the position of all these. I am not sure why I'm seeing that extra piece. What is that? Oh, it's my collection. We need to unhide. Yes, we're seeing the original collection. So all this geometry is actually the nodes object here, because this is in its geometry node group. We need to hide the original, so just click this little check mark. We won't see our original pieces anymore. We're just seeing the pieces that are instanced through this node group. A little bit confusing, but not horribly confusing, hopefully. I'm going to set this translation all back to 0, not moved at all. To turn that into a random translation, just click and drag from this little vector input here and type random. And now we have a random value plugged into there. So we can set a minimum and maximum. So let's try -6 and 6. Now we have our totally random movement. All the pieces just scattered through space. And you can see when I can select this node and press M to mute it. There they are: normal, random, normal, random. So far that's working well. Now we need a way to control this based on a control object. First step for that is to add the control object. Press Shift A in the viewport and get a new empty plane axis. And let's put that into our main collection and name it control. Okay, back to our nodes object. To access that empty in our node group, you can just click and drag it from the outliner like we did with the collection. It'll turn into an object info node. And what we need to do now is figure out how close this empty is to each point. You can think of, since each one of these is an instance, you can think of it as a single point with that mesh instance on the point. So we can think of each of these as a single point almost when we're working with them. I don't know if I got that right, but that's mostly how it seems to work. Switch this to relative so that if we move the empty, it's updated in here. And let's use its location, drag out from there, and type distance. And that'll give you a vector math node set to distance mode. The distance node, I'm using that because it will calculate the distance between the two vectors that are put into it, two positions. So we want the distance between the location of the empty and the location of each one of these. To get the location of each point here, we can simply use a position node. And the position node just gives you the position of every point of the current mesh, and it usually gets that right. So if I plug that into there, we now have the distance between the empty and each broken shard or piece. So now we need to take this value and use it to control the strength of this movement, this translation. So when the empty is closer, it will be less random, less moved, and when the empty is further away and the distance is greater, each piece will move further. To make that happen, we're going to use another vector math node. You can just duplicate this, change it from distance mode to scale mode. And in scale mode, all it does is multiply this value times this value. It's just a multiply node that lets you multiply a number times a vector. And a vector is just 3 numbers. If we put this scale node in here, now we can change the strength because we're multiplying the random number by bigger and smaller numbers. If our random number times 0, everything is 0. Random number times 1, random number times 1 is just the random number again. Random number times 2 is twice as great, twice as strong. So if we were to plug our distance into there, we would get total chaos. See what happens when we move our control. Something is happening. It is just very hard to tell, because it is too strong. We don't want to use the exact distance. We need to control that somehow. Because right now the distance between, say, the empty and this point might be like 40, which means it's getting multiplied. This is getting multiplied by 40, which is shooting it way off into the distance. Not what we want. Solution to that is to use a map range node. Let me make some room here. Nodes are getting all tangled up. And the map range node lets you set maximum and minimum for the input and then a maximum and minimum for the output. So let's say that the minimum input is 0, the maximum input is 10. The entire range of possible inputs is now clamped between 0 and 10. It's scaled to fit into there. The entire range of possible inputs is now clamped between 0 and 10. And for the outputs, let's just leave that as going from 0 to 1. So the scale could be 0, or the scale could be 1, or anything in between. Now if we move our control, I'm just going to move that on the y-axis. It's a lot more controlled what's happening, less crazy. But you'll notice that it never gets fully put back together. Like there's not enough room here. We can't see the bridge in its original state. To fix that, we can use a float curve node. Let me make some room. This is a bit like a color ramp, but for numbers. So right now we have our value going from 0 to 1. So here's the 0 and here's the 1. And we can change. Right now it is evenly interpolated from 0 to 1. It just goes straight up from 0 to 1. But if we were to adjust this, you can see that it changes how it looks. If I look at it in the side view, you can see that this curve almost matches what's happening here, because it's controlling it. So if I put this point right down here, we're getting more flat bridge. We can add another point here to tighten things up. You can also add a point up there to make it steeper, like a sort of a sharper transition. That's kind of neat. This is really customizable. There's a lot of different things that can be done. But now, you see, I've got a whole chunk of bridge here that's all put together at once, which makes this a lot cooler. This will be different for your case because everyone's size of their work will be different, the fractures will be different. So you won't be able to copy this part exactly, just this general shape here worked well in my original example. And if I move the control now, it's already looking much better. You can see there's a whole put together section of bridge, which is exactly what we want. Alright, so we have the basic mechanic working. You move the empty, the bridge builds itself and then comes back apart again. But it still needs some polish. And we're going to start by adding some random rotation. It would be neat if the pieces would rotate randomly as well as move randomly. That's super easy to set up. We just do the exact same thing but with a rotate node instead of a translate node. So just add a rotate instances. And we can duplicate most of the nodes here. Let's duplicate the random and the scale. So this will be our random rotation now, and we'll plug that into the rotation. And we can also use this distance as the scale. And let me move my control to see how that looks. Not too bad, though I think they're rotating too much, so let's turn that down a bit. We still have it going all the way to 6, which is probably too much. Let's try rotating from -2 to +2. And these values are in radians, not degrees. So, 2 is actually a pretty big number. That'd be like, yeah, I can't do that in my head. It's more than 180 degrees. It's a pretty big rotation. And that's looking quite cool. You can see each piece carefully orienting itself to fit in. And if we need a better view of this, you can click up here and enable cavity, which sort of highlights the edges of things just so you can get a better look at them. So everything fits together really neatly. Take a look right here. We're getting some pieces that sort of go through each other, and that's okay because it'll be moving fast enough that no one will notice, but we might be able to reduce that a little bit by limiting the random movement of these. Like, this piece here is moving through. It's going like this, coming down, and going through the bridge like this, so its random position took it from here all the way this way. So if we would limit its Y movement, it would come more straight down, and that would probably look a little better. So, super easy to change. Just change this. Right now we're letting it have -6 and +6 units of randomness in the Y direction, because it goes X, Y, Z, X, Y, Z. Let's just turn this down to -0.1 and +0.1. Try that now. Already a lot better. You see the rotation is really cool. The way that the float curve node is controlling it makes they sort of snap and rotate into place at the last moment. Really, really awesome. Okay, now we have the random rotation. We have the random movement. It is more or less a finished looking effect. But there is more we can do. If you hit play, or if you were to animate your control, let me do that. Let me animate my control. I'm going to put it here, press I, location. I need to see my frames. Let me go to the layout tab here. Okay, that's on frame 1. And I'll just skip to the end. Put it over here. I, location. That is extremely slow, but it'll work fine for this demonstration. Down here I can press A, T, pick linear. Now it moves linearly between the start and the end. Okay, it's too static, too still. You can see the pieces here in the air. They would look a lot cooler if they were sort of floating around, if they had a little bit of movement to them, so they didn't just freeze in the air like that. It would look a lot more magical. And that is not too hard to do. What we need to do is take some noise, animate it, just by making it move slightly, and then use that noise to affect our random positions. We'll just add another scale node, and multiply in some noise. And that's not too hard to do. We'll just take a vector math node and add the noise into our position we already have. So let's start with that. Let's just duplicate this scale node, switch it to add. Now you can see we can add or subtract from the positions of each one, which is perfect. Let's just add noise there. So get a noise texture. Actually, before we do that, let's organize some things. This goes with this, goes with this. This goes to that. Okay, and let's make some frames here. Press flower J, put a frame around the nodes. Flower J. Control J if you're not on a Mac. Also, I'm going to make a reroute here, a little dot. Just hold down Shift, right click, and drag. Put all these in a frame. Flower J. Okay, much nicer. We've got our nodes that control the translation, nodes that control the rotation, and the distance. Okay, next step is noise. Let's add a noise texture node. This is where it will all come from, and we'll start by just plugging the color into our add node. Doesn't change much, we need to animate the noise. To animate the noise, we need to give it an input vector here, so we'll just use the position as the input vector. Should work okay. It just gives it a frame of reference to work from, for the noise to be generated from. And let's add another vector math node. Vector math. And add is perfect. If we slowly add a little bit to the noise, it will move over time. We want to have a value in here that's constantly changing, so that the noise is constantly moving in the Z direction. And we can do that. We could keyframe a value in there, or we can just use a driver. Just click in the Z here, press pound, shift 3 to make a pound sign, and then type frame for the frame number, slash for divided, and we'll divide it by 250. So this will always have the value frame number divided by 250. A little expression like this is called a driver, and when you hit enter, that turns purple. So you can see it changes constantly. And now our pieces are scooting around a little bit slowly. So they're moving around too quickly, too much. So let's turn down the scale of the noise so it's less detailed, like 1.1, something in there. Okay, and I don't want to control the strength of the noise, so let's add another vector math scale node in here. Set it to scale so that we can quickly just change the strength of our noise. And our noise is only moving in one direction, only the positive direction here. And to fix that, we need to subtract a little bit from it. So just duplicate your scale node, switch it to subtract, and subtract 0.5 from your noise. By default, the noise texture comes out, this color value gives you 3 values between 0 and 1 because it's for colors. We want to use it as a vector, so we want positive and negative numbers, not just positive numbers. And to make that happen, just subtract 0.5, so that instead of going from 0 to 1, it goes from negative 0.5 to positive 0.5. Now we can scale that to make it as strong as we want. Like crazy strong. Now everything is ruined. It also shows a problem. You see that the noise is also affecting the pieces that are supposed to be still. They're supposed to be part of the bridge, but the noise is just moving everything around. To solve that, we can use this same distance to control the strength of the noise, so that pieces, shards that are closer to the empty will have less noise. Just duplicate the scale node to here, and plug in our distance there. Should do the trick. Okay, they're floating around, and you can actually see the complete part of the bridge moving through there. Looks very cool. They're floating around too much. Let's scale that down a lot. Seven looks good. Adjust to taste, of course. Alright, and you have the complete effect. That's it. You move the control, stuff moves. It's awesome. You can animate the control, you can animate a camera to follow that. There's quite a lot of options here. I also added a material to mine. To add a material, just put in a set material node here, and then pick a material, go over to the shading tab, and build whatever material here. I used an image texture of some stone. I didn't do anything complicated. I actually don't know a ton about texturing these little shards. You could probably find a good solution for that somewhere. So I'm just going to leave the material up to you on this one. Maybe we can cover that in the future. I also added a neat animated fog to my render. Animated fog added quite a bit of atmosphere and made it a lot cooler than I had expected. If you're curious how I made the fog, it's super easy. I wrote a whole newsletter on that. Let me see. On my newsletter here on the blend, it is, I think it's this one right here. I explained how to set up the fog. Super simple. It's a cube with a volume shader. And there's some nice explanation here if you're wondering. I'll link to this in the description so you can go read that. It breaks it down, makes it easy to set up. I highly recommend it. Adds a lot to the scene. So that's it. You've built a complete bridge. You learned how to fracture a cube, how to set up the geometry nodes, to move those pieces randomly and rotate them randomly based on their distance to a control object. All valuable skills to have in the world of Blender.